Hello everyone, this video covers lecture notes for week number 8. The main topic here is equations of quadratic type. Quadratic type just means that you can write the equation into a quadratic equation, and if you have a quadratic equation, that means you can solve it by either factoring. If you can factor it, you can use the method of completing the square, or you can just use the quadratic formula. So the quadratic formula. Remember, the quadratic formula works every single time to solve a quadratic equation like this. You just have to make sure that it's equals to 0, and that you know the values for a, b, and c. If that's the case, and you should memorize this formula, x is equals to minus b plus or minus the square root of b squared minus 4ac divided by 2a. Now this formula has either two real solutions, which answer this question, or it has two complex solutions, which we will talk about it later, or it has one repeated solution. Okay, and this is what I mean by two real, two complex, or one repeated solution. Remember, the solution is where the parabola crosses the x-axis. So here you can see that it crosses it at 2 points. So this will be two real solutions. Complex solutions means that it will not cross the x-axis, so the graph will look like this. So that will be two complex solutions. And one repeated one, it means that it crosses the x-axis at only 1 point, so it could be something like this. All right, let's do an equation where we have to use the quadratic formula, so you get used to using it. So here the value for a is 4, the value for b is minus 12, and the value for c is 9. If we plug this into the formula, we'll have x equals to minus b plus or minus b squared, which will be minus 12 squared, minus 4ac, everything divided by 2a. Right, then we evaluate the values inside the formula. So this is 12 plus or minus, this is 144 minus 144, should check that, divided by 8. So therefore this is 12 plus or minus 0 divided by a, which is just 12 divided by a, or you divide by 4, this is equals to 3 fourths, actually 3 halves. And notice that you only have one solution, which is this case, one repeated solution. Notice that in this case, in this particular case, you could just factor, because you have for x squared minus 12x plus 9 equals to 0. This is the same thing as 2x minus 3 times 2x minus 3 equals to 0. Therefore, that means that 2x minus 3 is 0 twice, so that's why it's the repeated solution. So this is easier to see why it repeats, and that you only have one. So therefore here you have 2x equals to 3, or x equals to 3 over 2. The issue with factoring is that it doesn't work all the time, but if it works, it is usually easier and faster than the quadratic formula, which this one works every single time, but it requires more work. All right, now we're going to use the information from last class, from week 7, to create equations of quadratic form. So this is a quadratic equation, and this is going to give you a quadratic equation of quadratic type. For example, this is what we did in last class. So therefore, g of x cubed is the same thing as 4 times x cubed squared minus 12 times x cubed plus 9, which is equals to 4x to the 6 minus 12x cubed plus 9, which is exactly this answer, this equation. All right, so now here is the part that is new. So the question is usually going to ask you to solve something like this, which is an equation of quadratic type. Again, this is not a quadratic equation, it's a quadratic type. This one is a quadratic equation. So you usually solve the quadratic equation by either factoring or the quadratic formula. And then for this one, you have to make the substitution. So remember, we just did this right now. For 4x squared minus 12x plus 9 equals to 0, the solution was x equals to 3 halves. This implies that therefore x cubed equals to 3 halves must be the solution to 4x to the 6 minus 12x cubed plus 9 equals to 0. However, we don't want x cubed, what we want is x. So therefore, x is going to be the cube root of 3 halves, or x equals to 3 halves to the 1/3. Now, in general, it's actually easier to solve it by substitution. In general, substitution is better. It's exactly the same thing we just did, but this is what I mean by substitution. You can say that 4x to the 6 minus 12x cubed plus 9 is equals to 0. And then you say let y equals to x cubed. So therefore this equation will become 4y squared minus 12y plus 9 equals to 0. And then you solve this. This is quadratic. So you can solve it using the quadratic formula or factoring, just like we did in the previous problem, just like we did here. And then you use that, and you have to either take a square root or a cube root to solve the problem, or a higher root. Now to solve this part, we use the following fact that when you take the cube root of a number, then doesn't matter if the k is positive or negative, you only have one solution, which would be the cube root of k, and it doesn't matter if it is positive or negative, the answer is no. Or remember, you can write this k to the 1/3. And if this number is negative, it doesn't matter. X will be the cube root of minus a, and the cube root of minus a is negative 2. Why? Because minus 2 is minus 2 times minus 2 is negative a. So if you're taking a cube root, it is okay if this value is negative, as you can see in this example. If you're doing a square root, this is not okay, and we'll see that very soon. Now, just to recap what we did in the last page, remember, an equation to be of quadratic form, it would look like this: aw squared plus bw plus c usually equals to 0, where the w could be any algebraic expression. This is the typical example. This is actually a little more tricky than usual, but this is a typical example. But if we go with the substitution I told you, technically you can say this is y squared minus 4y plus 3 equals to 0. And in general, this is easier to solve. So that's why I think that the substitution makes it easier, because from here you can even factor this one easily. This is y minus 3, y minus 1, so that implies that y is equals to 3 or y is equals to 1. Now, if you were solving this equation, this is the solution and you're done. But this is where you're solving. So this is where you do the substitution, and then you say this is y squared minus 4y plus 3 equals to 0, where y is equals to 1 plus 1 over x. Now, we already solved for the value for y. Y is either 3 or 1. So if y is equals to 1, this implies that 1 is equals to 1 plus 1 over x. That implies 0 is equals to 1 over x. And this part has no solution, but you have one more value for y. So if y is equals to 3, that implies that 3 is equals to 1 plus 1 over x, or that 2 is equals to 1 over x, which means 2x equals to 1, which means x equals to 1/2. And this is the only solution. Again, I do believe that the easiest way to solve equations of quadratic type is to write a quadratic equation first, solve it, and then do the substitution and use the solutions to get the answer you need. And we're going to do a few more examples so you can see how it works. For this example, let's start with the substitution right away. And this is the easy way to know what the substitution will be. Just look to the middle one, which is x to the 4, and that's what the substitution should be. So let y equals to x to the 4. So therefore that implies that y squared is equals to x to the 4 squared, which is equals to x to the a. That means that you can rewrite the equation as y squared minus ay plus 7 equals to 0. And this you can factor pretty easily. This is y minus 7 times y minus 1 equals to 0. And the solution to this would be 7, or the solution to this one is 1. So if the equation was this is the answer and you will be done. But that's not the equation. The equation is this one. But that's where the substitution comes pretty handy. So from here we have therefore that either x to the 4 is equals to 7, or the x to the 4 is equals to 1. Now this is the part where you have to be very careful. So let's look to this side. It says, what are the solutions of the equation x to the 4 equals to k? This one actually has 4 solutions. That's what the exponent tells you. And the solutions are this. X is going to be either plus or minus the square root of k. This is assuming that k is positive. And the complex solutions is plus or minus ki. Okay? Where I is a complex number, but we're not working with this right now. So for now, you can forget about this. So technically, solutions we have for now are plus or minus this should be the 4 root of k. So therefore the solution for this one, x will be plus or minus the 4 root of 7, and for this one x equals to plus or minus the 4 root of 1, which is just plus or minus 1. Now just to show you that you actually have 4 solutions, even though we only care about the real ones for now, x plus 4 equals to 1 is the same thing as x to the 4 minus 1 equals to 0. And then you can factor this as x squared minus 1 times x squared plus 1. And this one can be factored as x plus 1, x minus 1. And this one is x plus I times x minus I, which you don't have to worry about the complex numbers now. So you can see you have 4 solutions. All you care right now is about these 2, which are these 2 right here. The last part that we will do is to make sure that you understand how to take the n root, and this table is very helpful for that. So let's start with the first one. If n is odd and a is any real number, which means it could be positive or it could be negative, okay? Then when you take the cube root, just like we did a few minutes ago, then it has only one solution. And here is the perfect case. So here n is equals to 3. The value for a is negative a, which is negative and is fine because this is an odd power. So therefore the solution is the cube root of minus a, which is minus 2. Or the cube root of minus a is minus 2. Why? Because minus 2 times minus 2 times minus 2 is equals to minus a. But the solution is just minus 2. Now, what are the solutions to the equation x cubed equals to minus a? Well, this is exactly the same thing as this. So x will be the cube root of minus a. And we already saw it only has one solution, which is negative 2. One real solution. It actually has also two complex solutions, but we're not dealing with complex solutions now. So now, if n is even and a is negative, that is not a real number, and you stop there for now. So, for example, here, the value for n is 6, which is even. The value for a is negative a, which is negative. So therefore, this is not a real number. Again, it has a solution on the complex numbers, but we don't care about those right now. So therefore, on the test, if I ask you to solve this, you will say that x is the 6th root of minus a. Actually, when it's even, it's plus or minus, usually. But in this case, you say not a real number. And that's it. Or you can also say no solution on in the real numbers. Same thing. But if n is even and a is positive, then not only this has a solution, it actually has two solutions. That's the plus or minus that I mentioned right here. So here, for example, here the value for n is 4. The value for a is 16, which is positive. This one is negative. So this is a positive solution to the equation right here. Actually, it's the solution to this equation. And the solution is equals to plus or minus 2. Why? Because minus 2 times minus 2 times minus 2 times minus 2 is 16. And so is 2 times 2 times 2 times 2. So therefore, if this is positive, you are good. If this is negative, because there is no real solution. So here, the equation to this is x equals to plus or minus the 4 root of 16, which is plus or minus 2. Now, don't forget, and we talked about this multiple times before, that a radical is the same thing as a fractional exponent. So therefore, the n root of a is the same thing as a to the 1 over n. So therefore, the 7 root of 13 is the same thing as 13 to the 1/7 power in exponential form, and 4 to the 1/3 is the same thing as the cube root of 4 in radical form. Okay, so now let's look to the last example. Even though this doesn't look like it, this is actually in quadratic form. The difference is that the exponents are fractions now. And if you recall, I told you should look to the middle one when we do the substitution, which in this case, this is the middle term. And that's what we should call y. So y will be x to the 1/6. Notice that y squared is the same thing as x to the 1/6. Then we have to square everything. So this will be x to the 1/3, which, remember, this is the cube root and this is the 6th root. So therefore, you can rewrite this equation as y squared plus y minus 2 equals to 0. Okay, so this is the y and the 2 is there. And like the previous ones, you can just factor this easily. This is y plus 2 and y minus 1 equals to 0. So therefore, the solution for this part is negative 2 or 1. If this was the solution, this is the answer, and you'll be done. But this is not the equation. The equation is this one. So then you had to go back to the substitution. So the substitution was this. So that means that x to the 1 6 has to be negative 2. And this means that x to the 1 6 has to equals to 1. Now this one is not a real number. Why? Because technically this is telling you have the 6th root of x is equals to negative 2. And that's impossible, so this has no solution, or not a real number. But this one does. So here x will be equals to 1 to the 6th power, which is equals to 1. Here you have to be very careful because, so note, this is a very common mistake and is related to this table where things are even or are odd. A very common mistake people do is this. They say x to the 1 6 is equals to negative 2. That means x is equals to negative 2 to the 6th power, which is equals to 64. And then they say the answer is 64, and that's actually wrong, because the square root of 64 is equals to 2, not negative 2. So that's why this one has no solution, at least not on the real numbers. Okay? And the reason why it has to do with the explanation we did at the beginning here, where it is okay to take square roots of q roots and 5th roots and 7th roots of negative numbers if it is odd, but it's not okay if this is even. So the square root of a negative number doesn't exist, not in the real numbers. All right, so that's it for this week.